Hello, everyone, and welcome to today's webinar. My name is Philip Radukic, and I'm a product manager and senior consultant here at CI Experts, and as such responsible for the UPV web services, browser-based viewing, and associated technologies. Today, we are, at least for now, finishing our use case webinar series concentrating on various real-life use cases. These use cases we're supposed to show some examples on how the UPV ecosystem can be implemented to make processes run more smoothly in your company, how to save time and effort, and utilize the various features of UPV at its best. And today's part 10 of the series will be covering a topic helping in the daily business of any owner-operator as well as engineering partners and contractors, and that's quality control and management. As always, the session will be recorded and we will provide you the link to the recording subsequently by email. At any time during the webinar, feel free to use the questions panel and state your questions, and I will try to answer as many as possible after the live demo. And this being said, let's actually have a look at today's agenda. So we'll concentrate on a few examples showing challenges in quality control and management, and that's a really broad area to cover. So in our live demo, we'll actually have a look at the challenge: how can we do visual model quality checks? How can we actually report on information quality and utilize reports? And how can we enrich data that we can use for quality management and planning? So our final topic for this use case webinar series is one that the industry is facing during all phases of the asset cycle management. What is the actual quality of my data and thus of my digital twin? Building upon the previous webinar of as-is management, in case you've seen that. If not, you can actually watch the recording on YouTube. And a way to check if this is the case is necessary and crucial to the successful usage of a digital twin. So there are various approaches to handle these challenges, which in return require a lot of time and or specialized tools. And today we will look at a couple of easy approaches helping to ensure that data quality of the digital twin, and answer questions like, how do I see if the model is according to planning? How can I check if my model is up to date? How can I visualize the status of certain equipment on site? How can I check if naming conventions are being kept? And this webinar is merely going to have a quick overview of possible use cases that might inspire your own approach to these challenges. We're always open to suggestions and feedback as to how these features are utilized in your own environment, or how we can help evolve the solution to match your very own use case. Good, so what are the challenges? Is the model according to documentation? So what are the risks? Outdated models lower the quality of information. Are all objects covered by the digital twin, or do we actually have some missing objects, equipments, pipelines? So the risk here is, again, that missing objects lower the quality and the reliability of information, and thus the quality and reliability of a digital twin. Are naming conventions kept? Well, errors in naming make it hard to find certain assets and objects, and thus navigating through our digital twin. And then keeping track of schedules. What does this mean in this case? Well, for example, visualization of maintenances due or past due are harder to manage relying just on databases and tools only. So what is our solution here? Well, first of all, you can do a visual check of the model quality. The fact is we can identify changes instantly and take according measures. For example, use sketching or some space blockers to actually keep the digital twin up to date and thus again ensuring model quality. Check against subsequent changes. So recognize deviations and errors easily, again raising the quality of the digital twin. Conduct detailed reporting. For example, find objects not following naming rules, or also find some issues in the plant and report on these. For example, maintenance tasks that need to be done and similar. Again, ensuring also a seamless operation of your plant. And enrich the model information. Add additional information to model. Make it easy to track maintenance schedules, for example, or possible issues arising. And add additional information that is not contained in the original authoring systems or laser scans point clouds, and thus have actually more data to work with. This can be static, this can be dynamic. We'll have a look at different examples for this. This being said, let's actually have a look at our live demo. So let me actually take this aside a bit. We're now looking at our demo plant model, and one of the easiest ways to check if my model and engineering quality has been kept is, are actually all objects according to some layout plans. So for this, we can actually use the layout plans and map them into our 3D model. So in this case, I'll just pick a general arrangement drawing for equipment layouts and overlay it with our 3D model. With the Alt key pressed on my keyboard, I can now drag this with the mouse and make sure that everything is actually positioned as planned. So in this case, by being able to vary the height of the layer, I can see, yes, the pumps fit perfectly here, and also the equipment is located perfectly here. Or we can also compare this on this end where we have a lot of equipment overlaying each other. So I can basically pull this up to our vessel T201 here, and I can tell, okay, with this layout plan, this fits, and this one fits too accordingly. But this does not only work with general arrangement drawings. We could also just use a piping layout plan and do the very same thing here by just dragging it to position and checking again if the equipment and the piping is positioned according to the layout plans. As you can see here, this is actually looking like a perfect match. So what other options do we have? Well, we have the option, and for this, let me go into our laser scan mesh to see, okay, here in this empty space, we actually have a lot of space here. But in this case, I'll just go backwards. For this example, we have actually removed an IBC container that was in the way, but we can go the same way backwards and say, okay, when we did the scan, this was empty space, but now we actually have an IBC container placed in the middle of things, and we can use images, in this case it would be a panoramic image, to overlay it with our model to actually show things that are standing in the way, and thus ensuring again that our digital twin quality is meeting the requirements we have to a digital twin, being always up to date. And the example I picked here with the panoramic image, well, sometimes we just don't get to have a panoramic image. So instead, we just take a picture. And for that, I have prepared another example here. Let's go to a boiler room and perhaps switch to a different picture. No, let's take this one here. So again, we have a 3D model of this boiler room or heating room, and we overlaid a regular 2D picture, but this gives us the option to see obstacles that are somewhere in the way, and also ensuring some safety measures or, again, quality of data management. So in this case, we see, okay, there's something missing here. To ensure that this is added, for example, as an owner operator, going back to my engineering company and say, okay, please add this pressure sustainment vessel here to the model. So I could easily just create a markup and say change orders, for example, create a markup. And let me pick some freehand tool here and saying, okay, please add to model. Again, a tool that helps us ensure the quality. In this file, we can turn it on and off. And this actually get our model updated and also send this file to a contractor or to the engineering department to actually get this straight. So what else can we do? We can, for example, also use custom attributes to actually ensure some, well, equipment quality and checkups. So let me go back to my favorite station here and say, okay, I want to use custom attributes to handle the data quality of the valves here. So in this case, I added some custom attributes like condition, reason, action, where we can actually have a cascading, a dependent line of logic between the different selectable code list values. So in this case, I can say, okay, let's pretend this valve was okay. So under reason and action, I have no code list entry and C, so everything is okay, not necessary to enter anything here. But let's say I said it's not okay. So you see reason is highlighting red. Why is this? Because now I need to actually select, is it rusty? Does it have a leakage? Does it have multiple issues of, let's say, other? In this case, I'll say, okay, it's a leakage. And the action that needs to be taken, well, let's actually make a second check here. So, but how do I visualize this? I can double click on condition and it would highlight everything according to the custom attribute set. So in this case, we see which ones are okay, the green ones, which ones are not okay, red ones, and which ones are still unchecked or undefined, which would be the black ones here. And I can also go to reason by double clicking on it. So it would highlight by reason And now already see, well, okay, what does which color mean? In order to actually get the legend, all I have to do is open my custom attributes panel, and I will get a color key legend here to see, okay, these ones are rusty, the yellow ones do have a leakage, and the blue one is some other issue. And again, go to action and say, okay, I have several ones set for second check in this case. And let's say we've checked this and I found out, okay, this needs to be fixed instantly. It will automatically also change the color. And again, I can manage easily and visualize data regarding the quality of my processes, but also my quality of maintenance and similar. When I'm talking about quality of maintenance, let me turn off the custom attributes again, so the colors will revert to default. I can also use enrichment of data for quality management. How would I do that? So there's different approaches here. I can either use custom attributes to add them dynamically, like I've shown you with the code lists. You can also pick basically some free text to enter a free text comment, or I can use either static texts or like I did in this case, using our Excel import plugin to add data coming from third-party sources. This can be, let's say, some SAP PM system with an Excel export. But you can also utilize the API to directly connect from your outside systems, like an SAP PM system or any type of similar database-based systems where you actually hold your maintenance cases, and push this information live into UPV. So in this case, I see, okay, last maintenance was done January 1st this year. Next maintenance will be due in a year. For E240, it would be January 2nd. For my column here in the background, it would be January 3rd. For these two pumps, I added some information like March 11th and March 12th. So how to actually get this information in here? As I said, I used Excel import. So I can show you an example of such an Excel import file where I have a source attribute defined, a source value, and then I'm just adding attributes. And this could also be like vendors and fluid states and similar, to get additional information that does not come from the authoring system. But with the API, we can do very similar things, but just getting live data or data live during the runtime from your database and display it in UPV. And again, ensuring that the quality of information we have available is always up to date. So what else can we do with all this information? We can, for example, pull reports. So how will we do that? Let me actually make a report on our equipment and the maintenance turns here. So what I would need is name and I think it was last maintenance and maintenance due. And let's just generate a report here. So we have a lot of equipment where I did not import this information. So let me right click on does not exist and say hide this. And now I actually get a list of my different objects and their last maintenance dates, there when the next maintenance is due. And I can go ahead and save this away again to Excel and use this for further reporting or further analysis, filtering, comparison to other lists, and similar. Or, for example, colorize by some type of conditional formatting where maintenance due has been actually passed, and last maintenance has been longer ago than, let's say, a year in this case. So we can use this to, at any point, make sure that our data quality is kept, and also that our good data quality coming from outside sources is visualized and implemented in UPV. So what else can we do with reporting? I've shown you the example with the cascading settings for our valves here. So let me actually show you a pre-saved report here, which is valve condition. And let me actually remove all unknown ones. Again, right click on unknown, say hide. And I don't want to get a list of all those that are okay. So I'll hide those two. So now I have a list of valves that are not okay, and I have actually direct overview over them. What I didn't show in the previous report, I can click on any line in the report and zoom straight to the object listed there. But even more than that, so you see now condition is no okay, rusty, second check. Let's say we did a second check here and say, okay, it doesn't have to be fixed instantly, but fix it occasionally. And when I now go back into 3D, you see that fix occasionally has already been selected. So all these settings you can also do in your report. But what else can we do here with reporting? We can also use the reporting to check, as I mentioned in my introduction, naming conventions. Are they actually being met? So for this, I will just create new report and select, in this case, pipeline and pipe run. So I will get all the data from S3D, and since I did not pick all, but just selected, our list is actually very short. Great. And now we actually have a result here that I can also, again, export to Excel. Here we go. And in here, I could now select filters or even regex expressions that would analyze if the content of my fields is correct, if it follows the naming conventions set for the plant or not. And again, I can then set comments or custom attributes or markups, sending it back to the engineering department to correct that. Again, ensuring that our model and information quality is always on top level. Great. As I said, today, it's a very broad field, and there's, I'm sure, a lot of different use cases that you are actually using, or that you are working by, and I doubt that we can cover all of these in such a short webinar. So if you have any questions, feel free, go ahead, contact us anytime. And being at that point, I just noticed that our time's also coming to the end. Let's actually come to the Q&A. How do we set up the custom attributes? Okay, I had it, I think, open in the background already because I was doing some adaptations to the attributes file. So basically what we, for custom attributes, we set an ID name for a custom attribute, the way it will be shown, the source attribute that it attaches to, and then filters. We can have data types calculation. So there's different calculation types we can use here. For that, you can also consult our online help where this is all described in detail. More interesting is actually, that was the second question I read here. How do you do this cascading selection? In this case, I defined for condition, reason, and action, attach the attribute, custom attribute to the source attribute name, and have a predefined filter that's can actually be found here. So task is piping and unit system is recovery stage 1. So you can also concatenate filters and just use them up here, and data type code list. So for these 3 objects, we have unknown, no code list entry, no code list entry, NC as default values, and parameters, what actually the different, well, options are, and on which other code list it depends, or which other custom attributes. In this case, reason is depending on condition. No, condition is depend. Yeah, reason is depending on condition, and action is depending on reason. So all I have to do for valve state 1, 2, and 3, add my values, add the hex color code, and then I added here linked code list 1, which will actually give me the different condition states. So either it's by default unknown NC and C. If valve state 1, which is condition OK, then these only have the option NC. If it's not OK, then we have rusty, then we have leakage, multiple, and other. And for rusty, again, we have these options. So basically you do a list of cascading options, and when you load this into UPV, it will be automatically shown as I presented to you to have this cascading selection. But if you want to know further details on how to do it, you can also contact me after the webinar to set up a meeting to go into the details. Well, okay, there was a question, how do we import bulk information from Excel? I've already shown that too. With the Excel import plugin, you can define easy Excel lists to import additional attributes. And yeah, okay, I was waiting for this question. What licenses would be necessary to perform these tasks? Well, depending on your licensing model, you might already have everything you need. In some cases, for example, for the Excel import, you would need the SDK plugin. Also, through connect from third-party software or databases to UPV, you would need the API license. Or for the photo mapping, that requires the laser scan adapter. Besides that, all other functions, including also the PDF mapping into 3D, the projection, that's already included in the default UPV license. And if you're using our new concurrent user licensing model, basically all these licenses are already included in your license, so no additional license needed at all. So I just noticed I've already went over time. So I'd say thank you for your attention, and questions that I might not have been able to answer now during the webinar or after a live demo, I will be answering by email. Also, if you need some deeper consulting on how to implement certain use cases, including the ones from today, but also from past webinars, just let me know and we can arrange a meeting to actually discuss your requirements and the details how to implement it best in your case.